So you should be through with the diagram.
I'm done. Yes, I'm done.
Okay, let's write this statement down. The diagram shows the vertical cross-section LMN. The vertical cross-section LMN of a fixed smooth surface. Of a fixed smooth surface. Full stop. M is the lowest point of the cross section. M is the lowest point of the cross section. Full stop. L is 2.45 meters above the level of M. L is 2.45 meters above the level of M, comma, and N is 1.2 meters above the level of M. Full stop. A particle of mass 0.5 kilogram is released from rest at L. A particle of mass 0.5 kilogram is released from rest at L and moves on the surface until it leaves and moves on the surface until it leaves it at N. Until it leaves it at N. Full stop. Question A. Find the greatest speed of the particle. Find the greatest speed of the particle. Full stop. Question B. The kinetic energy. Find the kinetic energy of the particle at N. Find the kinetic energy of the particle at N. Question C. The particle is now projected from N. The particle is now projected the particle is now projected from N with speed v meters per second. With speed v meters per second along the surface towards M. Along the surface towards M. Full stop. Find the least value of V for which the particle will reach L. Find the least value of V for which the particle will reach L. Full stop. So that's the question. I will set for the solution. Question A says we should find the greatest speed. The greatest speed will be at the least point, which is m. Is that clear?
Yes, sir.
The greatest speed is at m. So take note of that. And take note that we are told that the surface is smooth. Do you get that now?
Yes, sir.
So because the surface is smooth, the total mechanical energy is constant. Because the surface is smooth, the total mechanical energy is constant. That is, loss in potential energy equals gain in kinetic energy, which implies that potential energy at L equals kinetic energy at M. Does that make sense to you? So mgh equals half mv squared. The potential energy at L, I have the height of L given to be 2.45. So the mass 0.5 times 10 times 2.45 equals 1 over 2 times 0.5 v squared. Because we are looking for the least speed, the highest speed. And we said it's going to occur at m. That's when it gains kinetic energy. Is that clear? So please multiply this for me. 0.5 times 10 times 2.45. That's 5 times 2.45. With your calculator, that will be what? 5 times 2.45. This is 5, 2.
12.25.
Yes, 12.25. 12.25 equals 0.25 v squared. Agreed? That's 1 over 2 times 1 over 2. That's 1 over 4. So v squared equals 12.25 divided by 0.25. Yes, with your calculator?
49.
49. So square root of 49 is 7.
7.
Do you get that now? Hence,
Yes, sir. Yes, sir.
the greatest speed equals 7 meters per second at m. So copy that. When you're done, let me know.
I'm done. I'm done.
Okay.
I'm done.
All right. B. What are we looking for in B? The question says we should find the kinetic energy of the particle at n. Now, there are two ways to it, but let's see. Potential energy at L equals kinetic energy at n plus potential energy at n. Is that clear?
Yes, sir.
So potential energy at L, we have done that. That's the left-hand side of A. So that's 12.25 equals kinetic energy at N plus potential energy at N. That's mgh now will be 0.5 times 10. The height now is 1.2 from the diagram. Can you see that? 1.2 times 1.2. So 12.25 equals kinetic energy at N plus, please multiply this for me, 0.5 times 10 times 1.2. That's 5 times 1.2, 6. Yeah. So KE at N will be 25 minus 6. That will be 6.25 joule. Now, on the alternative, before you write, hold on, you can equally say that kinetic energy at N equals mgh. Now, the h now will be the difference between the height at L and at N. That's 0.5 times 10 times the height at AL. That's what? 2.45 minus at N, 1.2. 2.45 minus 1.2. That's 1.25. So 5 times 1.25. Please do that for me. This is 5. 5 times 5, 5.
6.25.
6.25 joule. Please copy that quickly.
Then I'm done.
Okay.
I'm done.
Okay. Jason, we are waiting for you.
I'm done.
So now question D says, C rather, says we should find the least value of V for which the particle will reach L. And the projection took place from N this time. Let's go back to the diagram. And I want you to observe those values we have obtained. Initially, the projection starts from L. It will pass through M and goes to N. While coming from L to M, we said because it's coming down, there will be loss in potential energy and gain in kinetic energy. So you can see that at M, we obtain the greatest speed, which is 7 meters per second. Now, it moves from M to N. We obtain the speed to be 6.25. I mean, the kinetic energy to be 6.25. Now, while moving from M to N, there will be loss in kinetic energy because it's moving up. Hope that is clear. Now, you are projecting back from N to L to pass through M. Hope I'm communicating. According to the question, that the particle is now projected from N with speed V along the surface towards M. Will it stop at M? No. It's going to pass through M. That's what it means. So it will go back up. There will be loss in potential energy. Then there is tendency to come down back to M. Then it will be permanently at rest there. Why will that be so? Because of the height of M is higher than that of N. So, since we have answered question B, from B, kinetic energy at N equals 6.25. So, kinetic energy, which is half mv squared, will now be 6.25 equals 1 over 2 times 0.5 times v squared. Hope I'm communicating. So 0.25 v squared equals 6.25. V squared equals 6.25 divided by 0.25. Yes? What is that?
25.
25. So V will now be square root of 25, which is 5. Hence, the least speed equals 5 meters per second. Hope that makes sense to you.
So I don't understand the B part very well. Why did we did potential energy at N is equals to kinetic energy at N plus potential energy at N.
Yes.
I don't get the formula.
Okay. Remember on Friday, I said that if we are saying that an object is gaining potential energy at the same time is gaining potential energy at the same time is losing it, that we are not saying they are happening at different times. Both are happening together. Both are doing what? Happening together. So as the object is descending from L, it will move through M back to N. So there is kinetic energy, there is potential energy happening. At M, potential energy is 0. Potential energy here is 0. Why? Because it's at horizontal level. It's not at any altitude. Hope I'm communicating. But from M, it will be moving up. It will start gaining potential energy. Do you get that now? So,
Yes, sir.
it will be gaining potential energy. So here, we are going to have potential energy. Here, we are going to have kinetic energy. So reason for saying it is plus.
Okay, sir.
If you don't understand the first method, I think the second method should make sense. That's why I said, or kinetic energy at N equals potential energy at N. Now, the potential energy now, we now need to find the difference in height. The difference in height. Is that clear?
Yes, sir.
So that's it. Wẹ́yà dáìdù yẹn padà síbi tó wà yẹn kó jókòó síbẹ̀. Wẹ́yà máa dún lórí yẹn láàárọ̀ yìí. Kó dẹ̀ dá bọ́ọ̀lù yẹn padà sí 2. Tó bá fẹ́ kí n fún ẹ ní kò lórí. Dá padà sí èso wa. Wẹ́yà don't write it, let me know, please.
I'm done.
Okay.
I'm done.
Okay.
I'm done, sir.
So let's move on to another question. I want to give you the diagram. Please draw that diagram if I now give you the statement.
I'm done.
Okay.
I'm done.
Let's wait for you.
I'm done.
Okay. Well, please write. A lorry of mass 12,500 kilogram. A lorry of mass 12,500 kilogram travels along a road. Travels along a road that has a straight horizontal section AB. That travels along a road that has a straight horizontal section AB and a straight inclined section BC. Full stop. The length of BC is 500 meters. Full stop. The speeds of the lorry at A, B, and C are the speeds of the lorry at A, B, and C are 17 meters per second, 25 meters per second, and 17 meters per second, respectively. Full stop. Question A. Question A. The work done against the resistance to motion. The work done against the resistance to motion of the lorry as it travels from A to B is 5,000 kilojoule. Work done as it travels from A to B is 5,000 kilojoules. Full stop. Find the work done by the driving force as the lorry travels from A to B. Find the work done by the driving force as the lorry travels from A to B. Full stop. Question B. Question B. As the lorry travels from B to C, as the lorry travels from B to C, the resistance to motion is 4,800 Newton. 4,800 Newton. And the work done by the driving force is 3,300 kilojoule. The work done by the driving force is 3,300 kilojoules. Full stop. Find the height of C above the level of AB. Find the height of C above the level of AB. Full stop. Would you want to try that question?
Yes, sir. Yes.
Okay.
Yes, sir. Please, can you come again? As the lorry travels from B to C.
Okay. As the lorry travels from B to C, the resistance to motion is 4,800 Newton.
Okay, sir.
And the work done by the driving force is 3,300 kilojoule. Full stop. Find the height of C above the level of AB. But let me give you this hint. You can use the formula work done by driving force minus work done against resistance plus or minus. I want to generalize that place, so it's up to you where to use minus, where to use plus. GSM sine alpha equals change in kinetic energy half m v square minus u square. So work done by driving force, work done against resistance, potential energy. Hope I'm communicating. Kinetic energy, potential energy, resistance, work done against resistance, work done by driving force. So if you want to use this formula for A, what do you think will not be there?
Distance.
No.
GSM scientific.
God bless you. GSM sin alpha. There will not be potential energy. Jason, hope that is clear.
Yes, sir.
And if you want to approach it in another way, all well and good. But to me, this will afford you to answer both questions.
I'm done with you.
Okay, let's wait for others. Hope you are conscious of the unit. Hope you are conscious. Now, the 5,000 kilojoules, that will be what? That's going to give you 5 million.
Yes.
5 million joule.
Yes.
Take note of that.
So I'm also done with you.
Okay, let's wait for Mr. Jason. Jason, how far?
So I'm on it.
Okay. Ibukun, what did you get?
7,100 kilojoules.
Abolaji.
7,100 kilojoules.
Jason, what is wrong?
I'm still solving it.
I think this formula is straightforward to apply.
Yes, sir.
Ibukun and Abolaji, did you apply the formula?
Yes, sir. Yes, sir.
Okay, proceed to B. Why Jason is still doing A? So we're able to get 7,100 kilojoule.
Yes, sir.
Or 7,100,000.
Yes, sir. That's very good.
Okay. Proceed to B. We are using the same formula, But this time, there will be potential energy. Now, the question is, are you going to use plus or are you going to use minus? That's what I want to check now.
Minus.
Minus. Why?
Against the motion of.
Because it's moving up.
Yes.
Against the gravity. Correct. You guys should be true with this now. You are done.
Yes, sir.
Okay, let's wait for the remaining two people. What's the problem? Ibukun, are you there?
Yes, sir.
Jason.
Sir, I got an answer, sir.
Okay. Ibukun, how far? Did you get an answer, Sha?
Sir?
Did you also get an answer, Sha?
No, sir.
Okay, Abolaji, what did you get?
I'm not sure about 24.
Jason, what did you get, Sha?
16.8.
Okay, let's wait for Ibukun Jehovah. Ibukun, are you making progress?
Yes, sir.
Okay.
Oh, sir, is it the same driving for the work done by driving force that we use?
Is it the same one?
Yes, sir.
Why don't you read the question? Is it not the same? Is it not the same lorry?
Sir, I'm coming now. Soon get it.
Okay. And you have been given the driving force for that. So you are not paying attention to details of question. You are wasting time. You have been given the driving force in that question. The question says, as the lorry travels from B to C, the resistance to motion is 4,800 Newton, meaning that FR is 4,800 Newton. And the work done by the driving force, you have been given work done by driving force. That is FDS has been given, which is going to be 33,000, 3,300 kilojoule. So 3,300 kilojoule, which will now mean 3,300,000 joule. So you have been given FDS. Hope that makes sense now. Now, using this formula, work done by driving force has been given 3,300,000 minus work done by frictional force, or again resistance, that's 4,800 times the distance from B to C, 500 meters, minus GSM. I've told you that GSM is the same as potential energy. So that will be mgh now, because the H aspect of it is the G sign. Just hold on. So I want to change this one to mgh. mgh. So the mass, what's the mass? 12,500 times 10 h equals change in kinetic energy. What's the speed at C? That's final velocity, final speed. The speed at C is 17 minus the speed at B, 25. This is what we are going to use. So Ibukun, what do you get now? Ibukun?
So I got 24 meters.
So 24 is correct. So Abolaji, you are right. So JC, you must get 24 for each. You guys should go and sit down properly and get the interpretation of this formula very well. I think the formula is straightforward to use. So let's see another one. Jason, are you done?
Yes, sir.
Okay. Make sure your own curve is perfect. So draw that diagram quickly.
I'm done with the tag. I'm done too. So I'm done.
Okay, please write. The diagram shows the vertical cross-section of a surface. The diagram shows the vertical cross-section of a surface. Full stop. A and B are 2 points on the cross-section. A and B are 2 points on the cross-section, comma, and A is 5 meters higher than B. Full stop. I take everything again. The diagram shows the vertical cross-section of a surface. Full stop. A and B are 2 points on the cross-section, and A is 5 meters higher than B. Full stop. A particle of mass 0.35 kilogram. A particle of mass 0.35 kilogram passes through A with speed 7 meters per second, moving on the surface towards B. Moving on the surface towards B. Full stop. Question A. Assuming that there is no resistance to motion. Question A. Assuming that there is no resistance to motion, comma, find the speed with which the particle reaches B. Find the speed with which the particles reaches B. Full stop. Question B. Assuming instead that there is a resistance to motion. Assuming instead that there is a resistance to motion, comma, and that the particle reaches B with speed 11 meters per second. With speed 11 meters per second, comma, find the work done against this resistance. Find the work done against this resistance. as the particle moves from A to B. As the particle moves from A to B. Full stop. So that's the question. Take it as assignment to be submitted tomorrow. I must not ask for it before you submit it. Is that clear?
Yes, sir. Yes, sir. Yes, sir.
Okay. So bye.